Okay, as I said yesterday, water is made of two ions, hydrogen ion and hydroxide ion. The water molecule can undergo self-ionization. Self-ionization means it can dissociate into two ions, and this happens uh, continuously. If I have two water molecules like this, H2O and H2O, one of them can donate the other one hydrogen ion. So this one becomes hydronium ion, H3O plus. The other one that lost hydrogen, I mean this one on the left, lost hydrogen, it will change into hydroxide ion. So a water molecule gains hydrogen ion, becomes hydronium. A water molecule that loses hydrogen ion becomes what? Hydroxide. This cannot happen in many molecules, just a few molecules like water. So if we define self-ionization, it is the reaction in which water molecule produce ions. Again, the reaction in which water molecule produce ions. We can write it in another way. H2O dissociates into H plus and OH negative. This hydrogen ion is captured or taken by what? By the second water molecule to become hydronium ion. This molecule remains in the medium. The concentration of hydrogen ion, as I told you yesterday, is 10 power negative 7. This is the concentration of hydrogen ion in pure water. Pure water. This is the concentration of hydrogen. The concentration of hydroxide is also 10 power negative 7. This means the concentration of hydrogen, H plus concentration equals concentration of hydroxide. Both of them equal 10 power negative 7, or you can write it here like this, 1 times 10 power negative 7. The solution that has equal concentrations of hydrogen and hydroxide is called neutral solution. Neutral solution. That's why pure water is neutral solution. Not only pure water, some solutions like uh, some solutions of salt are also neutral. So again, neutral solution has equal concentrations of hydrogen and hydroxide. If we multiply hydrogen concentration and hydroxide concentration, we get this number. Even if the solution not neutral, if it is not neutral, you will also get this. If it's acidic, if it is basic, if it is neutral, the same. All of them will give you this number. If you multiply hydrogen ion concentration, this bracket called concentration, these brackets. So I read it like this: hydrogen ion concentration times hydroxide ion concentration. The product is 1 times 10 negative 14. This information is very important, very important. You have to memorize this. Memorize this rule. Why? Because we need it to calculate the concentration of hydrogen. If OH is known, you can calculate hydrogen. If H plus is known, you can calculate hydroxide. Why? Because you know this number. If you don't know it, if you forget it, you will never be able to answer the question. I'll give this symbol a name, ion product constant for water. Ion product constant for water, Kw, H plus time OH minus. Here, if I added acid to water, I told you before, acids dissociate or decompose in water and produce hydrogen ion. This hydrogen ion will increase acidity or make the H plus ion concentration greater than OH. So H plus concentration will be more than 10 negative 7. It can be 10 negative 1 or 10 negative 2 or 10 negative 3. All these values are greater than what? Greater than 10 negative 7. Again, when we add acid to water, to pure water, the acid dissociates and produce hydrogen ion. This hydrogen ion will increase the concentration of hydrogen of water. So now the water is not pure, is not neutral. It is acidic. Why? Because H plus increased in it. H plus increase means what? Means it is greater than 10 negative 7. I told you in the negative, we do the opposite. Negative 1 is greater than negative 7. Negative 2 is greater than negative 7. The smaller the number, the greater the value. So here, H plus is greater than 10 negative 7, and we call the solution acidic. It is not neutral. When I add base, the base has OH ion. This base dissociates in water and give us hydroxide ion. The hydroxide ion increases the OH. So when OH increases, so H decreases according to Le Chatelier. Remember from the previous term, if I increase OH, H will decrease. So H plus will be less than 10 negative 7. It will be 10 negative 8, 10 negative 9, 10 negative 14. All these numbers are less than 10 negative 7. Okay. So basic solution, it's one in which H plus is less than OH negative. Here, acidic solution in which H plus is greater than OH negative. How we make solution acidic or basic? It's done by adding acid or base to water. I think it is clear. Here we have a question. Sultan, can you read it? Can you read this question? Unmute yourself.
If the H plus in a solution is 1.0 times 10 to the power negative 5.
Mhm.
Is the solution acidic, basic, or neutral? What is the OH, the power minus of this solution?
Very good. Thank you. Here, if the H plus is 1 times 10 negative 5, is the solution acidic, basic, or neutral? Let's answer the first part of the question. Here, H plus is 10 power negative 5. Ask yourself, is 10 power negative 5 greater than 10 negative 7 or less than 10 negative 7? 10 negative 5 is greater than 10 negative 7 because I told you if we talk about negative numbers, the great value is smaller. 10 negative 7 is less than 10 negative 5. So this solution has high concentration of hydrogen. Why? Because 10 negative 5 greater than 10 negative 7. High concentration of hydrogen means it is acidic. This is the answer of the first part. It is acidic because the concentration of hydrogen is great. It is larger than 10 negative 7. What is the OH negative? Let's go back to this rule. Concentration of hydrogen times concentration of hydroxide equals 10 negative 14. Here, I need concentration of hydroxide. Concentration of hydroxide. To calculate it, it's very easy. Just divide 1 times 10 negative 14 over the concentration of hydrogen, which is 1 times negative 5. You can use your calculator or you can do it directly. Just subtract these numbers. 14 minus 5 equals 9. But we add the minus or the negative sign before it. So the answer is 1 times 10 negative 9. This is the concentration of what? Of hydroxide. You notice here that 9 plus 5 equals 14. So the product must be 14. This solution is acidic because negative 5 is greater than negative 7. The solution is acidic, as I said. And here to calculate OH, just divide Kw, which is 10 negative 14, over H plus. This value, I can change it in the exam or in the quiz. I will change this or this, but this value is fixed. I can't change it. There is another confirmation that the solution is acidic. The concentration of hydroxide, OH, as we calculated, less than concentration of hydrogen, which is 10 negative 5, or less than 10 negative 7. So this is another confirmation that the solution is acidic. OH plus is what? Low. We can apply this, classify each solution as acidic, basic, or neutral. Here we can see 10 negative 10. 10 negative 10, it is less than or yes, less than 10 negative 7. So it is basic. It is basic because hydrogen ion is the value is not great. We can apply this here. 10 negative 2 means OH is high. So this is basic, and so on. In this question, I gave you the hydroxide ion concentration, and I ask you to say it is basic or acidic. The answer is very easy. H plus equals 10 power negative 11. Why? Because negative 14 minus negative 3, negative 11. This value is small, smaller than negative 7, so the solution is what? Basic. There is something called the pH concept. pH is abbreviation of power of hydrogen. Power of hydrogen. It's a scale from 0 to 14, and it tells us the solution is basic, acidic, or neutral. If the pH equals 7, if the pH equals 7, the solution is neutral. If it is less than 7, the solution is acidic. If it is more than 7, the solution is basic. This is important. You have to know. 7 neutral, less than 7 acidic, more than 7 basic. How we calculate pH? We use a very simple rule. pH equals minus log H plus concentration. And if I give you H plus concentration, 1 times 10 negative 3. What is the pH? Just do like the rule. Minus log, then put this number. 1 times 10 negative 3. In the calculator, it will give you 3. 3 is less than 7, so it is acidic, and so on. So the pH of a solution is what? The negative logarithm of hydrogen ion concentration. You have to memorize this definition. The pH, power of hydrogen, is the negative logarithm of hydrogen ion concentration. In pure water, the pH is 7. Why? Apply the rule. Minus log 10 power negative 7 equals 7. Let's answer this one. What is the pH of a solution of hydrogen ion concentration? 4.2 times 10 negative 10. This is H plus concentration. Okay, so apply the rule. pH equals minus log, and put this number after the log. 4.2 times 10 power negative 10. 4.2 times 10 power negative 10. I can use the calculator. Minus log, then bracket 4.2 times 10 power negative 10. Then close your bracket. Equals 1.2. I have to make this again. Minus log 4.2 times 10 power negative 10. Equals 9.37. It must give you positive number. That's why I repeated the calculations. The answer is 9.37. 9.37. 9.37. Do you think it is acidic or basic? I told you if it is greater than 7, it is basic. The solution is basic. Uh, Finally, I'd like to tell you if you have the pH and you want to calculate the hydrogen ion concentration, just do something called anti-log. Anti-log. What is anti-log? Anti-log is to press shift plus log in the same time on the calculator to give you the pH, to give you H plus. So again, H plus, if you know the pH, just do H plus equal anti-log and put the pH after it. Okay, thank you so much. And we continue tomorrow. We will take the strength of acids and bases. Thank you. Goodbye.